Here we learn different methods to do transformation technique. There are generally three ways. There is no specific way or any general method for finding integral of a given function. But here we learn three methods to finding integral of a function. Let's do here. Here you can see that we have okay we have integration by transformation, that is you are already seeing in your screen. We have three methods to do integration by transformation method. First one is method of transformation, method of substitution, method by parts. First we learn integration of algebraic function. Algebraic function is what? Algebraic sum of function will be there in this form. Okay, so first thing we learn here, integration of algebraic function. Integration of algebraic function. Algebraic function. Okay, so we have various ways, but I am explaining only four kinds of algebraic sum of functions. First one is ax plus b power n, in this form will be there. Second will be 1 divided by 1 plus x square, this format will be there. And third one will be 1 divided by root under 1 minus x square. This kind of integration we are going to learn. Fourth one will be 1 divided by x root under x square minus 1. So these concepts are very important while doing integration. This will use in physics, in chemistry, okay, physical chemistry. So we are going to learn integration by algebraic function. This could be in the form of ax plus b power n, and we have 1 divided by 1 plus x square. Another way will be 1 divided by, another format will be 1 divided by root under 1 minus x square, and fourth one will be 1 divided by x root under x square minus 1. Okay, so these things we are going to learn over here. First kind of question I'm going to solve. Right, here we have to find integration. Okay, suppose dx divided by root under x plus root under x plus 1. How can we find the integration of this? Okay, so this could be solved in this way. You are seeing that this is what? Here root x is irrational number, and here root x plus 1 is irrational number, sum of irrational number in the denominator. So I need to remove this one denominator. I need to remove the denominator which is having irrational functions. What can I do? I need to rationalize it, then it will be solved easily. Okay, let's do here. I'm just going to rationalize it. New subscriber, thank you. Those who are new, welcome to my channel. Here we are seeing that plus sign, so I need to put here minus. Whatever I am writing in the denominator, the same thing will be written on the numerator in this way. So now easily we can solve here a plus b, a minus b, this function. Okay, a plus b, and we are seeing that a minus b, so it will be a square minus b square. I'm going to put here. So in this way we can solve this one. Let's do here. This will be integration dx, then root under x minus root under x plus 1, then here root under x square. Okay, so root x square minus root under x plus 1 whole square. These things will be there. Now this can be solved in this way. Here we have integration, then dx, then root under x minus then root under x plus 1, then divided root x square is x minus root under x plus 1 square. This square root will cancel and we have x plus 1. यहाँ पर आएगा x plus 1. Then this could be further solved here. So integration dx root under x minus root under x plus 1, then divided x minus x minus 1. This will cancel. This will cancel. So we'll go ahead. Here these things will be solved. Integration dx, then root under x minus root under x plus 1 divided by minus 1. This negative will go up, so I can write here negative, and then root under x minus root under x plus 1, then dx. Then dx easily we can write. Now इसको split करेंगे. Okay, so integration root x into dx, and this minus integration root under x plus 1 dx, then constant c will be there. Okay, so this will be solved in this way. That is, here we have minus, जहाँ नहीं समझ में आएगा you can ask. So here we have integration dx and minus minus plus. So here we have integration root under x plus 1 dx, and then plus minus minus plus, then plus c. So this will be x to the power 1 by 2 into dx integration, then here x plus 1 power 1 upon 2 dx integration plus c. Now we know that if something is there in this format, suppose x to the power n into dx integration, this could be write as x to the power n plus 1 divided by n plus 1 plus c. So I'm going to use this formula over here. So it will be minus x to the power 1 by 2 plus 1 divided by 1 by 2 plus 1. Now same thing, this will be solved here, plus x plus 1 1 by 2 plus 1 divided by 1 by 2 plus 1 and then plus c. plus c. So we have here so we have this value, that is minus x to the power 3 by 2, and here we have 3 by 2 plus x plus 1 3 by 2, and here we have 3 by 2 plus c. So this will be right in this way. Okay, this minus 2 by 3, then x to the power 3 by 2 here. Okay, minus 2 by 3, x to the power 3 by 2, and we have here plus this 2 will go up 2 by 3, and then x plus 1, x plus 1, then we have 3 by 2, 3 by 2 over here now, and on the last this constant c. So this is what integration of that one. This one is the detail overview, detailed explanation of the integration, that is I have done over here this integration. Okay, first what you have done, you have just rationalize it, and once you rationalize, you have this expression dx root under x minus root under x plus 1. So that is further solved in this way. Okay, we have this format, integration root under x minus root under x plus 1 into dx. So we have minus root under integration dx, integration root under x dx plus integration root under x plus 1 dx plus c. So we have done this integration over here with this formula, integration x to the power n dx, very general formula we have, that is equal to x to the power n plus 1. If you like my video, please subscribe, please like and share among your friends. Here n plus 1 plus c. So I have done this one with the help of this formula. Here x to the power 1 by 2 you are seeing, but dx is there, so it will be 1 by 2 plus 1 divided by this exponent here, this power over here, 1 by 2 plus 1. Same thing I have done for x plus 1 power 1 by 2 plus 1, so that is here, and on the last I have written the result. So this is the solution of this problem. Okay, we will move ahead, okay, so that it will be very clear. Okay, try another question. I have one problem, that is integration 3x plus 5 and divided by root under 7x plus 9 into dx. So here you are saying that 3x plus 5, this algebraic sum is somehow different than this one. How can we represent this one in the form of this? Okay, so we need to represent 3x plus 5 in the form of 7x plus 9. So what we'll do, we'll write 3x plus 5 in this format. So this could be write as 1 coefficient a, then 7x plus 9. Why? Because here we are saying that okay, x is multiplied with a constant and then it is added by a constant value. The same thing I have just written this variable with constant a and then added one constant over here in this way. So this is the approach by which we can write 3x plus 5 in this format, so that our integration will be easier. This term will be written on the top in the numerator, so that will be divided by this one, and overall our all the expression, all the terms will be in the numerator format, and we can easily find out the integration. Let's do it. Here, I can compare here 3x plus 5. You are seeing that here we have 7ax plus 9a plus b. So I can easily compare the variables. So 3 will be compared with 7a, and this constant 5 will be compared with 9a plus b is equal to 5. So a is having value 3 by 7. I can substitute this value over here. So a is having 3 by 7 plus b equal to 5. B equal to 5. So it is 27 by 7 plus b equal to 5. So we have b equal to 5 minus 27 by 7, and we can easily find out the value for b. So here we have 35 divided by 27 by 7 minus 27 by 7. So b equal to here 5. 15 minus 7 is 8. So b equal to 8 by 7 we have, and a equal to 3 by 7. Now we can easily put this constant over here, so that 3x plus 5 could be written in this format: a bracket 7x plus 9 plus b. Let's do it. So I'm just going to write this one: 3x plus 5, 3x plus 5 in this format, that is a is here. I'm writing here. In the next step I will write, so here 3x plus 5, a is having 3 by 7 value, you can see over here, and then 7x plus 9 we have, and b is having 8 by 7 obviously. So you can easily see that this 3x plus 5 will be in this format. It is changed into this format, this one, and now we can substitute this value over here in the place of 3x plus 5, so that our integration will be easier. So let's solve here. 3 by 7 and then 7x plus 9, 7x plus 9 plus 8 by 7, and divided by root under 7x plus 9, and then here we have dx. So this integration will give us in this format. So let's do here only. Here I can write integration 3 by 7, 7x plus 9 dx. I'm just going to split it down: 7x plus 9, then integration 8 by 7 dx, then root under 7x plus 9, and on the last plus c. So this is there. We can easily cancel this one, or we can just do the this process. So we have this, once we cancel, we have root under 7x plus 9 in the place of numerator dx, then integration is written over here 3 by 7. This coefficient will come before this integration, and then 8 by 7 similarly will come just out of this integration, and this will be 7x plus 9. This power half will go up and it will change its sign, so it will be just minus 1 by 2 on the top, and then we have dx plus c. Is there any problem? If you like these steps, please do like, and please subscribe if you have not yet subscribed my channel, and share among your friends who are not knowing the integration, how to do integration by transformation. Let's dive into the problem now. Here 3 by 7, and this power is 1 by 2. So 7x plus 9 power 1 by 2 was there, so I'm just adding here plus 1, and here's coefficient 7 is there, so I'm just writing 7 in the denominator, because the coefficient of x is 7. So here 7, and this whole 3 by 2 1 by 2 plus 1 is 3 by 2, so I'm writing here 3 by 2 in the denominator, so that our calculation has been finished over here for this integration part. And now we can do also here. Why I'm using this one? Because this is what root under can be write as power 1 by 2 and power 1 by 2, but it is integration, so 1 by 2 plus 1, because I have already discussed here. I'm just going to use this formula over here. If suppose I'm going to rationalize here, suppose x to the power 1 by 2 over here and then dx, so this integration will give us x to the power 1 by 2 plus 1, and whatever is there in the power, that should be here 3 by 2. Okay, so this could be solved in this way. Here we have x, instead of x we have 7x plus 9, so that will be here, power will be same, and the coefficient of x will be written in the denominator as I have done here. So here, any problem? No. Okay, so here 8 by 7, and then this minus 1 by 2 will be added with 1. Okay, and then the coefficient of x is 7, so 7 will divide. Okay, here we have 7x plus 9 and then minus 1 by 2 plus 1. This 7 will be divided, and then minus half plus 1 is going to be half, and then plus c. So 3 by 2, so this 2 will go up, and this 3 will cancel. Okay, and this 7 and 7 multiply, so we are having 2 by 49 over here, and 7x plus 9 power 3 by 2, power 3 by 2. Clear? Yes. And we have here 8 by 7, so 8 by 7 into 7, this 2 will go up. Okay, so here in, and then we have here minus half plus 1, that is root under 7x plus 9 is there, and plus c. So you can easily see that we have this expression, that is 2 by 49 7x. Okay, 7x plus 9 3 by 2 plus 16 by 49, 16 by 49 bracket. Okay, 7x plus 9 power 1 by 2, or root under 7x plus 9 plus c. So this could be our result. Here you can write 16 by 49. So same thing I can go over here. On the last I can represent this format here, that is 2 by 49, then 7x plus 9 power 3 by 2 plus 16 by 49, and then 7x plus 9 root under plus c. Okay, so now I can easily take common from here both, and I can do further calculation here. So here you are saying that the same this quantity is here, so I'm taking common 7x plus 9 root. Okay, root under I'm taking common, and 2 by 49 is also there here, the 2 by 49 I'm also taking common. 2 by 49 also I am taking common. So what will be remain over here? 2 by 49 is just come out, and then we have here 7x plus 9 we remain only here. Okay, and this term is okay already taken out, so we have here 8 by, we have 8 only, we have 8 only, 8 by 1, or we have 8 only, these things. So we have 2 by 49 root under 7x plus 9, and then this 8 plus 9 is 17, so 7x plus 17 plus c. So we can write easily. Okay, on the last step we had 2 by 49, and then this term 7x plus 17, and then bracket 7x plus 9, and this is what our final result, final solution of this problem. If you have a further doubt, you can just ask me. I have done all the overall explanation over here. You can see how I just gone through the steps. I have root integration. Let's summarize it once again. integration 3x plus 5 root under 7x plus 9. So you are seeing that this algebraic sum is somehow different than numerator. So I just convert this numerator in the form of denominator. So what I have done here, 3x plus 5 is equal to, here you are seeing that the x is having constant value as a coefficient, and then it is added by a one constant. So what I have done, 3x plus 5 is having in this format that a constant is going to multiply with the denominator term, and then one constant is added with here. Constant is added with here, and just I got the value for this variable a and b by comparison. So we have a equal to 3 by 7 and b equal to, we have 8 by 7 we got over here. And then once I founded the value for a and b, then I can substitute over here. So 3x plus 5 will be replaced in this way. So a is 3 by 7 and b is 8 by 7, put it over here. 3x plus 5 is going to replace substituted by this expression, so I have just written over here, and then I just split it down, and you can see that this will cancel. So we have root under 7x plus 9 and then dx 8 by 7, and then root under 7x plus 9 power here negative. And now I just uses this concept here, integration x to the power n into x to the power n into dx, that will be x to the power n plus 1 and divided by n plus 1. So this is very wonderful formula and very standard one in the integration. So you should also by heart it. Yeah. And then here root under x 7x plus 9, and okay, I have done this one. So power will be just added. Here already power is half, so I have added 1, and that is going to divide here. And one more important thing, that the x is having a coefficient 7, so this term, after integration will divided by the coefficient of x. So here 7 is going to divide it, and similarly for here we have also. So we got this result, and on the last we have taken common, and then we put it the result over here. Okay, Asle Davis, hi, how are you? Okay, this is true, yes. Technical friend. Okay, I'll do it. Rungikuta method to solve. Okay, I'll do it. Thank you. If you have a further any comment, just let me know. Let me know through the comment. Everyone, yeah. Thank you. Let's move ahead. So this is the way to do the integration by transformation. Very, very important. Wherever you go, either you are going to derive, physical concept, either in physics or chemistry, so you need to have an integration there. That's why it is very important. Okay, for computer science students, this is very, very important. Okay, so we have another question that is very important, and you will enjoy it, I hope. Okay, let's do it to solve this one. That question is we have. Okay, let's solve another question. Integration x minus 1 then root under x plus 1 then dx. Okay, we have to do. You have already seen in the previous one that here we have in the denominator format, that is in the division format, but here it is in the product form. So what we are going to do, you can see that this one is irrational, okay, irrational term, and this is what rational term. So our technique is to find it out, this rational term in this in this format. So let's do here what I just going to write. I'm going to express x minus 1 is in this format. So first we need to do let x minus 1 okay, should be right at in this format. So I have one coefficient a, and that is going to be multiplied with x plus 1, and then one constant value is going to be added here. I just added over here, and then okay, I need to get the value for a and b. I need to find. So let's do it. Here x minus 1, ax and ba plus b. Now we can easily compare the value for variable and then constant. So variable is x, so here we have, x is equal to ax, and okay, we have constant term a plus b, that is here equal to -1. So we have x cancel, so we have value for a is 1. Once I cancel, so a is equal to 1, so I'm putting a equal to 1 over here, substituting the value for a is 1, b equal to -1, so b equal to -1, this will go the right side, so b equal to, we have -2. So a is 1 and b is -2. I'm going to substitute these values over here. So x minus 1 could be written as this format. So here I'm just going to put here integration x minus 1. So here a x plus 1 plus b. So x minus 1 is replaced by this, and then we have here x plus 1 integration. Okay, so let's do it. Here a is equal to 1, so a 1 have put it here, and then b is here, so b is having -2, and then I can just have this root under x plus 1 into dx. You can just multiply here to make further easier steps. So x plus 1 is going to multiply with root under x plus 1, either root under x plus 1 is multiplied with x plus 1, so we have this, and then dx, and then -2 integration x plus 1 root under x plus 1, and then dx plus c. If you like, please subscribe my channel and like, and whatever the comment you can put here, okay, that will be appreciated over here. So here you are seeing that we have x plus 1, and then root under same quantity you can see over here, and then minus root under x plus 1, then dx plus c. Now it is very easier to find out, to go further ahead. So here let x plus 1 and root under x plus 1, so both can be write as here power 1 and here power 1 by 2. So I can write x plus 1 and power 1 plus here 1 by 2 will be 1 plus 1 by 2 will give you 3 by 2, and then dx minus 2, this will be x plus 1 and power 1 by 2, then c, this dx plus c. Okay, so let's move ahead. I have this term, so I'm gonna to use over here this integration is going to solve here. Once again I'm writing, so 3x, okay, x plus 1 3 by 2 dx minus 2, and x plus 1 here, okay, 1 by 2 dx plus c. Now you can see that this is in this format, right? Okay, x to the power n, and then dx integration, so this could be write as x plus x to the power n plus 1, and whatever the power is here, that is divided here n plus 1, and here c constant term. So I'm going to use this one here, and the coefficient of x is 1, so a 1 is written in the denominator. So and 1 is going to multiply with anyone, no, okay, the value will not going to change over here. So here x plus 1, and then power 3 by 2 is going to added by 1, and whatever we have is this one, and that is going to divide over here. Okay, we have done over here, and then x plus 1 here power 1 by 2, so that will be added with 1, and we got this 1 by 2 plus 1 3 by 2 over here. I can easily write here 3 by 2 over here, and then plus c. Okay, so here we have x plus 1 and okay, 3 by 2. Here we have 5 by 2, and then we have 3 by 2 here. 5 by 2 minus we have 2, and this 2 will go up, and then 3 x plus 1, and I have here 3 by 2 plus c. So you can see that here we have 2 by 5 x plus 1 power 5 by 2, here 4 by 3 of power x plus 1, 3 by 2 plus c. This could be our result. This is the result. Okay, any problem? 2 by 5 x plus 1, 5 by 2 minus 4 by 3 x plus 1 by 2, and I can take common, and so that I can go ahead. Okay, better to write in the product format. So let's, here x plus 1, 3 by 2 is going to be common, so x plus 1, 3 by 2 is going to be common here. So what is remain here? 2 by 5, and x plus 1 is there. Okay, is there only, and here we have 4 by 3 remain, because it is already taken as common, here. Okay, so now we have x plus 1, 3 by 2, then I can solve here. 3 and 5 LCM is 15, and then 15 is going to divide 5 3, so 3 into 6, and then x plus 1, then we have 5 into 4, 20 c. So x plus 1, 3 by 2, and we have here 6x plus 6 minus 20 divided by 15, and plus c. So here x plus 1, 3 by 2, then 6x, and here minus 14, right? Minus 14, and divided by 15 plus c. I can take here common. 2 I am taking common, so 2 I am taking common, so it will be 2 by 15, and then x plus 1, 3 by 2. If you like it, please subscribe my channel. Please like more and more. I am getting very less like. Please, yes, do a favor. Okay, so here I'm taking 2 common, so here I have 3x, 3 to the 6, and 2 here, that is 7. 3x minus 7. Now it is better way to write this one as compared to this one, because we have 2 term, here we have a single term, 3x minus 7 plus c. So better to come to this result as compared to this one, because here we have 2 terms and here we have only 1 term in the product format, so it is better way to represent the solution. That's why, if you are not representing, no issue, but it is good idea to go for this one, so it should be better practice. Okay, any problem? If you have any problem, please write in the comment. Hi. Over. Let's solve one more question. We have one more question you can solve. Just evaluate x square divided by 1 plus x square and dx. Here you are seeing that in the denominator it is just incremented by 1, whatever given in the numerator. So we will try to write down in the format, okay, so that the some part of numerator will be looking like, some part of denominator. So if I'm adding here 1 and then subtracting 1, so we'll achieve some look of denominator in the numerator. So let's do it here. You can see that the some part of denominator will be appear on the numerator. So x plus 1, 1 plus x is, suppose I am writing here. So you can see that 1 is incremented over here, but I need to fix it, so I need to also subtract it by, so that it will just give the same result over here in the denominator. And 1 plus x square and then dx over here, 1 plus x square and then dx is over here. So we have here minus 1 and minus 1, you will cancel, so we have here, okay, we have this result. That's why I'm not going to cancel here, I need to represent in this format 1 plus x square and then minus 1 and then 1, 1 plus x square and then dx. So this will be further split in this way, that is this part and this part will be same, no? So 1 plus x square and then dx square dx, minus here we have 1 divided by 1 plus x square and then dx plus c over here. Okay, so this will be cancelled because both are similar, identical, so I can cancel it and it will give us identity. So it will be cancel over here. So 1 into dx is there, and then okay, 1 divided by 1 plus x square dx plus c. See here I can, and now this integration will be x and it will be tan inverse x. So we have here tan inverse x. Okay, we have a various trigonometrical function. So we will learn algebraic sum of functions, like sine x, cos x, or sine theta, cos theta, sec square theta, cosec square theta, sec theta and tan theta, and cosec theta or cot theta. So various ways are there, like sine square x could be write as 1 minus cos 2x by 2. Similarly, I can write cos to the power 3x is equal to 3 cos x plus cos 3x by 4. So that will we'll see later on. So here we have x minus tan inverse x plus c. This is the result of this one. So it is very, very important. It's looking tiny, but it is very, very conceptual. So today we have this much only. In the next time we will come and we will solve more, okay, more integration of trigonometrical function. We will solve more, and then okay, there's so many things are there to discuss, but within this limited time we cannot do. So thank you for being with me. Please subscribe, share among your friends, and do like more and as possible by you. Thank you so much for watching my videos and being with me. Thank you so much. See you in the next time. Bye bye.